Hey everybody, this is Games Plus James and welcome back to our Unity RPG tutorial series. Now in this episode we're going to take a look at making sure that our camera doesn't move off our map. So if I just play the game here, when we start things moving, we see we have all this blue space. I just loaded it into the previous area, but that's fine. We have all this blue space off to the left, which is no good to us. And we walk down to the bottom. Well, okay, there just happens to be nothing down the bottom of this map. I'll just reload our first area again. But the problem is our camera is showing all this space off to the side, which obviously we don't want to see. As far as our players should be aware, the edge of the map is the edge of the map and they shouldn't be able to see anything outside that. So we want to make sure that our camera doesn't show any of this area here. So the way we're going to use this is by setting up a separate kind of box area that our camera can move around within. So just to quickly start off, we're going to create a new empty object that we will call our bounds, because that's our boundaries that we don't want our camera to go beyond. And we're going to add a box collider 2D to it and make sure it's a trigger so it's not affecting anything else in the world. We can see it appears here in the middle, and I'm just going to zoom out a little bit, and I'm just going to scale it up on the x-axis so it's wide enough for our camera to be able to move around in, because we want to be able to see to the edge of this map and maybe a little bit of the trees at the side here. So I'm just going to move this over so now it's inside the map, so we won't see any blue, because if we zoom in, we can see it's a little bit too far over to the left. So I'm just going to pull it inside the map just a little bit, and we can see some trees on the right if we walk over there. And then we need to do the same on the y-axis, so we're going to scale it up on the y-axis, and again we'll want to see a bit of trees at the top and make sure that we can't see any blue at the bottom. So what we're going to say basically is that our camera can't move beyond this area at the bottom. And how can we make that happen? Well, basically the way we're going to do it is say that the edge of the camera can't go beyond the edge of this box. And how would we know? We need to work out what the width of the camera is at any particular time and what the height of the camera is. We can't just use there's no value that we can just immediately get that, because people will be playing this on different size monitors, different size screens and stuff like that. So we need to allow for all those and have it be able to automatically work out the screen size along the way. So the way we're going to attack this is, for example, with our camera, if we go to our camera here, we move it from the center point of the camera. So what we need to know is, if we know what half the size of the camera is on the x-axis, so half the width of the camera, if we know what that is, then we know that we can't let the camera move, or we need to make sure the camera moves within half its size from the edge. So what we need to work out is, say on our bounds here, we need to know what the minimum value on the left is and what the maximum value on the right is, and say, okay, if the center of the camera goes to the edge here, then what we need to say is you can't be at the edge, so you need to move in whatever half the size of the camera is. It's very simple when you see it in action, so the best thing to do is probably just to dive into it and start adding it to our camera script. So we'll go into our camera controller script. We'll open this up in MonoDevelop, and as I said, we're going to need to we'll obviously need to know what the boundaries are on our bounds box here. So on our camera controller, we'll obviously need a reference to that bounds box. So that'll be a public box collider 2D that we'll just call this our bounds. Then we'll need to know what actually we call it bound box. We'll need to know what the values are at the each edge of the box. So we need to know what the minimum x and the minimum y values are, and the maximum x and the maximum y values are, because obviously we want our camera to be limited to the sides and at the top and bottom. So what we'll say is we're going to create a private vector tree, which will be our minimum bounds, and we'll create a private vector tree that will also be our maximum bounds. And then in our start function, what we'll do straight away is say, okay, our minimum bounds should be equal to on our box collider that we set up, which is our bound box, what we can do is get the bounds that are on that and set them to be the minimum. And what that'll do is it'll return the value of what is the lowest x and the lowest y of the box collider. So if we go look at our bounds here, what we can see is it'll return this value down here. So that's as far left as we can go and as far down as we can go. It's a handy, simple little thing built into Unity by default. And then what we can say is, just like we did with our minimum bounds, we can say our maximum bounds is equal to our bounds box dot bounds dot max, like that. Okay, so now we know what the size of our box is. So we're getting somewhere to start off with to move our camera within. The next thing we need to know is, how wide is our camera? So on our main camera here, on our main camera, it has a camera component attached to it already. So we're working in our camera controller script, but our camera component here is what controls the size of the camera within the world, especially using our orthographic size here. So if we go to our game view, if we adjust our orthographic size, we can see it zooms in and out and we get a different scale on the world. So obviously you can work out from this that our orthographic size is controlling how much of the screen we can see. So we need to use that orthographic size to work out what position our camera is within the world, basically. So the way Unity handles this as well is that our orthographic size is actually not the full size of the camera, but half of the vertical size of the camera. That's just how Unity kind of calculates these things within the world. So our orthographic size, so say we have it set to be size 5 here, what it actually means is that's 5 units in the Unity game world. So if you look at the grid in the background of our scene view, we have 1, 2, 3, 4, 5. There are 5 units within the world of Unity, and you can see that that is equal to half of the height of the camera. So that's a handy shortcut way of realizing what the orthographic size actually represents within the world. But when we know what half the height of the camera is, we also know that we can put that to use within our script. So to get the orthographic size, we obviously need a reference to this camera component. So we'll have a private camera component that we'll call the camera. And then what we need to know to move the camera around within the world is we need to know half the height, which will just be the orthographic size here. But we'll also need to know half the width so that we can move the camera in when it's going too far to the left. We know how much to move it in from the left. So we'll have a private float for half height, which we'll just set to be the orthographic height. And then we'll have a private float for half width, which we'll have to work out with a relatively simple little formula. So in our start function, what we need to do is get the camera, and we'll say that is, we obviously need to get the component of camera that is attached to the same object that our camera controller script is attached to. And then what we need to do is we need to set our half height value, and we already established that that is the orthographic size. So we can just say the camera dot orthographic size, like that. And then we need to work out what the width of the camera is. And the width of the camera, well, basically we can work this out by what resolution we're using in our screen. So we have free there at the moment. Normally most computers will probably have 16:9, but there's lots of other different screen resolutions, 4:3 and stuff like that. So what we can do is say, well, we know what our orthographic size is. That gives us half the height. So we could use the same thing to get half the width if we multiply whatever the resolution of our screen is. So say it's 16:9, we could multiply our orthographic size by, if we divide the width of the screen by the height. So 16:9 refers to it's 16 across by 9 high. So if we divide that value and then multiply it by the orthographic size, what we'll end up with is half the width of our screen. So we'll just say the camera, well, we could say the camera dot orthographic size, or we could just say our half height, because we already have that value, multiplied by screen dot width, and that'll tell us what the width of the whole screen is, or the whole active screen in our game at least. Screen dot width divided by screen dot height. So I'm just going to save this, and we'll see these values in action back in the game. So we'll just let it compile for a second, and we should get our bounds box slot appearing here in our camera controller. Okay, so we've got our bounds box, so I'm going to drag our new bounds box into that slot there, and then I'm going to switch over to debug view so that we can see all the values as they get assigned to our bounds box. So at the moment everything is 0. If we hit play here, oh, we don't want to be in the maximize view, I'll just go back to this view. So we can see now we've set our minimum bounds and our maximum bounds, our camera. We have our half height is 5 as we expected it to be, and we can see our half width is now 10.7. So roughly looking at the screen here, you can see that our screen is pretty much twice as wide as it is tall. So that's absolutely perfect. That's what we wanted to do. So now that we know we have the half the height and the width, we can put that into action to make sure that the camera doesn't move. And we can use a very simple technique that's built into Unity, which is a thing called a clamp. And a clamp will basically say, okay, here is a maximum value and a minimum value, and then we will use whatever our current value is and make sure it can't go below the minimum value and it can't go above the maximum value. So we want to do that for both our X and our Y axis. So in our update loop here, we're going to create a new float that we'll call clamped X, and we're going to set that to be equal to matf.clamp. So this is the function that we use to clamp a value. So we can see we get our little tooltip that says we have our value that we want to use, then we have the minimum value that it can be, and the maximum value that it can be. So the value that we want to use is obviously wherever our camera currently is in the world. So that'll be our transform dot position. If I could spell, that would be lovely. Position dot x. So it's our x position in the world. We don't want that to go below whatever our minimum bounds dot x, whatever that value is, and we want to add on half the width of the camera. So that will make sure that the center of the camera never goes too far to the left. So that's the minimum value we wanted to have, and then the maximum value will be our max bounds dot x minus half the width of the camera. So again, we don't want it to go excuse me, we don't want it to go too far to the right. So we'll do that, and we'll hit our semicolon at the end. And we want to do the exact same thing with our Y value. So what we can actually do is just copy that whole line, paste it down below. Oh, that should be a float at the start there, and just change all the X's to be Y's, like that. And instead of half height, what we want to use, or sorry, instead of half width, what we want to use is half height. So max bounds that Y, and take away half the height. No, not half height, just half height. Okay, so now that we have these clamped values and we have it, we know that our Y value here won't go below any of these. What we can do is then apply that back to our transform dot position. So we can say transform dot position dot sorry, not that anything, just transform dot position is equal to a new vector tree, and so the new X value we want to have is our clamped X value, and the new Y value we want to have is our new clamped Y value. And then on the Z axis, of course, we don't want it to move at all, so we'll leave that as transform dot position dot Z. That shouldn't be a capital T there, just monodevelop being a little bit annoying. And that's basically all we need to do to make sure our camera doesn't move around within our world. So if we save that and we'll go back into the game here, compile, and once it's finished compiling, so say for example we're going to move our camera just so it automatically appears off to the left, although I should try and center on the player so it would try and go off to the left anyway. But if we hit play now, what we should see is now our camera won't go over to the left. I won't walk off the screen just yet, but we'll see no matter how far over I walk, the camera stops going to the left, and now it'll still follow the player off to the right, of course. And as it follows us down, it goes down to the bottom of the screen. You can see our bounds box is actually a little bit high, so our player's feet kind of appear below the ground. But that's fine, that doesn't really matter too much. But as you can see now, the camera is locked into place, and suddenly this doesn't just look like a map in a random blue spaced world. It actually looks like a physical, more physical and real place, because our camera isn't just wandering around all over the place. But there is one issue with this, of course, is that at the moment our camera needs to know where the bounds box is when we start the game. But of course we're keeping our camera active when we move between scenes, and if we walk into a new scene, suddenly the bound box of the camera controller isn't assigned. It's still saving the values we have set up, and they just happen to be working for this map, which is just purely coincidental, because if I walk over to the right here now, well, okay, this just happens to be bearing out for us that this fits in with within this map. But if we were using a different size map, so if we go into the house here, so as you can see now the camera is kind of clamped to only show the top left of the house here, so it's clamped up there. But what we'd really want is it to be centered within that house. So what's happening is, of course, there's no bound box, so it doesn't really know what settings to use, so it's just using the previous settings that it has. So what we're going to do is create a very simple script that we will attach to our bound boxes. So I'm just going to save this scene just to use as an example, and we're going to load up back into the main scene rather than the village, where you can see there's a huge map for our player to be able to walk around in. But what we want is we're going to create a new bounds box in this level 2. We can't assign this to the camera because obviously if the main camera is being brought in from the previous area, it won't know what that is. So I'm just going to switch this back to normal view, add our box collider to it, make sure that it is a trigger. We'll scale it up a bit. And we're just making sure that we can only move around within this certain specific area here. Actually, we'll make sure it's a lot thinner, like this, so we can only see within this area here. So what we need to do is, as soon as we load into this scene, we need to tell the camera what the coordinates and stuff of this bounds box are. So we're going to create a new script, create a C# script that we'll just call it the bounds script, and we'll open this up in Unity, or in Unity, no, in MonoDevelop, sorry. And what we need to do is, on our camera controller, what we're going to do is create a new function on the camera controller script. So we'll create a new public void, what do we call it? We'll call it set bounds. And what this needs to do is, basically we're going to tell this, what will happen is, on our bound script we're going to call this function straight away as soon as it loads, and what it'll do is it'll tell us, our camera controller script, okay, here's the new box collider to use as the bounds of our camera. So we're going to need to send in whatever the new box collider is, so a new box collider 2D, and we'll call this the new bounds. And basically all we'll do is, okay, we'll just say now our bound box is equal to our new bounds, And then we just need to do the same calculations that we did at the start on this new object. So we will just get our min bounds and our max bounds, and we're going to pop them in there like that. Our camera size shouldn't change because we're still using the same orthographic size and stuff like that. Our screen shouldn't have changed at all. So we'll save that. And that's basically all we need to do. So now we have our new bounds and our max bounds set. So when our camera is trying to move within the world, it'll be set for them just perfectly. And then our bounds, in our bounds script here, as I said, what we need to do is straight away set the value, or call, the function on the camera controller to set the box collider. So we'll obviously need a reference to the box collider that's attached to this one. So we'll create a private box collider 2D that we'll just call bounds for simple sake, and then we need to have a reference to the actual camera, so that'll be a private camera controller that we'll call the camera. And basically all we need to do in our start function is, first of all, we need to find our bounds box. So we'll say our bounds is equal to get component box collider 2D. Then we need to find our camera. So our camera is equal to find object of type camera controller. And then finally we need to, on that camera script, we say the camera dot set bounds, and the bounds we want to set are our box collider up here, so that will be our bounds box collider, and we send that off to the camera controller. We'll save that, convert that. I'm going to delete the update because we don't actually need that in our script. And now if we go back into the game, we'll let that compile. We'll obviously need to attach this script to our bounds box. Once it finishes compiling eventually. There we go. So we'll attach our bounds script to it there. There's no values that we need to set on that. I'm going to save this. We'll switch back into our original, or our village scene. We'll add the same script to our bounds box here as well, because if we create a bounds box, we need to set it to all of these. And now if you play the game, once we load into the new level, it's actually okay. So what's happening is, because of course we have our, if we go back to our main scene, we have a camera already here. So what it's doing is finding that camera first, and then that camera is being destroyed and our new camera is still being active within the world. So what we need to do is tell our, if we go to project settings and script execution order here, basically what we need to happen is our bounds function should only run after the rest of our after our camera has already been destroyed. So our main camera, what should happen is our main camera in this one should go, okay, there's already a main camera being brought in from our other area, so this camera gets destroyed, and then we run our bounds. So what we can do is basically just say in our project settings, we can go to script execution order and add our bounds script. So what happens is our bounds, we've set it to be, it gets set in here as 100. We can see here we have default time and then bounds. So what that means is our bounds script will be called after other scripts have basically executed. So what should happen is our main camera should automatically execute, and then our bounds script will happen. So if we go back to our, we need to apply that. Go back to our village again, hit play. And once it's running, oh, it's compiling the boundary script in the corner there. Or sorry, not compiling the boundary script, but compiling the script order. Okay, well that hasn't worked either, of course, because Unity is a bit fickle sometimes. So another simple way we can fix it is if we go to our camera controller, what we can do is in our update loop is just say if our bounds, our bound box is equal to null, then what we should do is say, okay, our bound box should be equal to find object of type bounds. So what that'll do is it'll find our bounds within the world, and then once it finds those bounds, we need to set what our min bounds and our max bounds should be based off of that new bound box, and then we'll be able to have the correct values in place within our game. So we'll save that, go back into the game again. Oh no, we got a bit of an error. Oh yes, of course, we don't need to find the object. We need to find the object that has the type bounds, but what we need to assign to the bound box is the box collider that is attached to it. So we need to get the component on that object that is the box collider 2D. Just so it knows it's assigning the right thing to the bound box, of course. Save this, let it compile, and we should see once it finishes compiling let it play and go back in here. We can see that our camera is actually clamped smaller now than where the player starts off. So although we got this error down here, that is just a one line error, it's not a repeating error. So that was just what happened the very first time we loaded into the game, and then we can see now that our camera is clamped to this area. So it's not clamped to the same area as the previous world, but we've actually clamped it just the way we want it to. So there you go, that's how we can make sure our camera is clamped within the world, although our player is still able to move wherever he wants to. So it's important, obviously, to make sure that your player's boundaries match up where the camera boundaries are. But there you go, our camera is clamped, it's not moving around crazily, and that's just what we want to happen. So thanks for watching this episode, and I'll be back with some more RPG tutorial goodness very soon.